So when we're solving rational equations, we have to use the same rule that we always use when solving any type of equation, and that is whatever you do to one side of the equation, you have to do to the other side of the equation. So when we do it, what happens is that we're creating equivalent equations, and those equivalent equations are just easier to solve. Now, the good news is if we have an equation that contains fractions, one of the things that we can do is if we multiply both sides of the equation by that lowest common denominator, what happens is that all of the denominators end up canceling, and we have a much nicer equation to solve at the end. So here's our first example. 1 over x equals 9 over 2x plus 8. So the first thing we want to do is identify what is that lowest common denominator of all of the fractions in the equation. So the denominators I have are an x and a 2x, right? So the lowest common denominator would be 2x. I know some students are going to say, well, isn't it just x? But remember, it's kind of weird because we say lowest common denominator, but it's actually the bigger part, so that both the x and the 2x will go into it. Okay, so 2x is our LCD. So I want to multiply both sides of the equation by 2x. So make sure that it's okay to do, right? I'm doing the same thing to both sides. So I'm going to create an equivalent equation. So I'm going to go ahead and put a 1 under my 2x because I know a lot of students like that. And I'll go ahead and put a 1 under my 8 just so that everybody looks like a fraction. So what's going to happen on the left-hand side? So I have 2 over x times 1 over x. I'm sorry, 2 times x times 1 over x. Right, so those x's are going to cancel, right? An x in the top and x in the bottom. We just get a 2 for the left-hand side. On the right side, right, that 2x multiplies in. So I'll go ahead and write it out. So 2x times 9 over 1 times 2x. You see how those 2x's get to cancel? I'm just going to get a 9. Come back up, so the 2x times the 8. I don't need 1 times 1, that's just a 1, so I don't need to write that. So what do I have? I've got a 2 equals, I canceled my 2x's, I just have a 9 plus 2 times x times 8, that's 16x. Okay, well, I've canceled all my denominators. I have this equation that's equivalent and much nicer to solve. So this is a linear equation. So that means we want to get the x term by itself first. So I will subtract 9 from both sides. So negative 7 equals 16x. And divide both sides by 16. So x equals negative 7/16. So here's our next example. 2 over x minus 4 equals negative 10 over 6x minus 5. So our LCD will be both parts, right? They have nothing in common. So I multiply. So what I like to usually do, I'll write it down here, I guess. So 2 over x minus 4. I'm just going to kind of space it out. Negative 10 over 6x minus 5. So we're going to multiply both sides of the equation and just the numerator. So it's not the same thing top and bottom, right? It's the same thing to both sides of the equation. So when it's an equation, it's same thing to both sides. If it's just an expression, like you're adding fractions, then it's same thing top and bottom. So there's that. Here's one for the left side then. X minus 4 times 6x minus 5. Same thing, top and bottom. And stick a 1 under it if you feel better. Now, as soon as you multiply by that common denominator, the fact that it's a common denominator means the denominators you have are factors, right, of what's up in the top. So the x minus 4 cancels the x minus 4. So I'm left with 2, the numerator that was there, times 6x minus 5. And then I'm at my equal sign. So coming over to the other side, right, the 6x minus 5 can cancel 6x minus 5 that we multiplied in. So I just have the negative 10 times the x minus 4. So 12x minus 10 equals negative 10x plus 40. So again, this is linear because my x's are to the first, so we'll get all of our x's together on one side and our numbers together on the other. So I'm just doing that. So I have 22x. Those guys are gone, those guys are gone. There's my equal sign, equals 50. So divide both sides by 22. So 50 over 22, or 25/11ths. Okay. 2a plus 12 over a equals 10. What is the lowest common denominator? Well, I only have one denominator, so that'll be the lowest one. So just an a. So both sides are going to get multiplied by a. So a times 2a plus 12 over a equals 10 times a. Right, so there's my a, same thing to both sides. So distribute on the left, 2a squared. So when the a multiplies my second term, it's going to cancel because there's an a in the top and an a in the bottom. So 2a squared plus 12 equals 10a. So this equation is quadratic. So quadratic equations, right, you need to get a 0. So we're going to subtract 10a from both sides. And I went ahead and put it in its usual spot in the middle there. So 2a squared minus 10a plus 12 equals 0. So we have to factor that. So the first thing I'm going to do is take out the common factor of 2. So a squared minus 5a plus 6 equals 0. Keep factoring. So multiply to 6, positive 6, but add to give negative 5. So 2 negative, so a minus 3 times a minus 2. So then you can set your factors equal to 0. So the 2 out in front, that cannot help this be 0. You need a variable to help you be 0. So then either a minus 3 equals 0, so that means a equals 3, or a minus 2 equals 0, or a equals 2. So this next example is going to be just like that one. So if you want to pause and try this one on your own. So our LCD is going to be x. Multiply both sides by x. Okay, so same thing to both sides. Distribute. So we'll get x squared. When I multiply the 6 over x, right, the x's get to cancel, so I just get plus 6 equals negative 5x. Oh, well, gee whiz. We have the exact same equation. So add the 5x to both sides. And factor, well, it's almost exactly the same. X plus 3 times x plus 2. So either x plus 3 is 0, x is negative 3, or x plus 2 is 0, which means x is negative 2. Okay, 2 more examples. So rational equation, rational because I've got some fractions in there. Decide what your LCD is. So look at the denominators that you have. So there's a 5 and there's a 3, so the LCD would be 15. So we're going to multiply both sides of the equation by 15. So I'm just writing that out. So because the left-hand side had the first term, the x plus 2 over 5, and the minus 1, I put it in parentheses so that I'm careful to distribute my 15 to both. So when it multiplies the first one, right, I'm going to use that 5 from the bottom to cancel part of that 15 for that first one. So that's really just going to be 3 times x plus 2, because the 5 will cancel. Then I have 15 times negative 1, so minus 15. And that gets us to our equal sign. So for the right side of the equation, the 3 goes into the 15 5 times. See, that's kind of how it's canceling. I didn't want to do it here because it really stays at 15 as it distributes. I just have a 1 multiplier over here. So the 3 goes into the 15 5 times, so that means I'm left with 5 times x minus 2. So we'll go ahead and get rid of our parentheses, distribute. So 3x plus 6 minus 15 equals 5x minus 10. Linear. So let's just tidy up our sides. We want to get all of our x's together. So 3x minus 9 equals 5x minus 10. I'm going to go ahead and subtract 3x from both sides. Negative 9 equals 2x, minus 10. Add 10 to both sides. So 2x equals 1. So x equals 1/2. Okay, so I have this last example, and I'm going to show you a strategy that only works sometimes. And that strategy is cross-multiplying. So cross-multiplying will work when you have one fraction, and only one fraction, equals one fraction. So you can't have like 3 terms. So there's only one other example on this page where cross-multiplying would be an option. Can you guys see which one that one would be? Which one of these other examples is set up where cross-multiplying could work? One fraction equals one fraction. Right, it was the second one, right? This one here would have been a cross-multiply. One fraction equals one fraction. All of the other examples on the page have 3 different terms in the equation, so not an option. So cross-multiplying. If one fraction equals one fraction, then we can cross-multiply and set those two equal. So product of the means equals the product of the extremes, if you know that sort of thing. So we're going to multiply the top of one fraction to the bottom of the other. And then set that equal to the product going the other way. And since they're binomials in this example, I'm wrapping them in parentheses so that I'm careful to distribute. So we're going to go ahead and FOIL. So x squared plus 2x plus 1. We still have to solve what's left. Sorry. So we just cross-multiplied. We came up with something that's equivalent, that doesn't have a denominator in it. We still have to solve what's left. And so since I can't really tell what's left here, I'm going to multiply everything out and just see what we've got. Okay, so I just multiplied the left side. Now we're going to do the same thing on the right. So that's going to be x squared minus x minus 6. So it's quadratic, but those are both x squared. So when I bring them together, when I try to combine, right, they're just going to add away. So my x squares are gone. So now I'm down to linear. So 2x plus 1 equals negative x plus 6. So let's go ahead and add x to both sides. And subtract 1 from both sides. So we get 3x equals 5. Or x equals 5/3. Okay, so you don't have to cross multiply. We could have multiplied by the LCD, just like we did in the second question. And we would have gotten, by the way, we would have gotten exactly that same second line that we have, or first line that we have here. It's just a different way to do it.